here's our next set of identities, and this time we've got tan involved in this identity. So let's just remind ourselves, tan x is, if you remember, so katoa, opposite over adjacent. And so for this one here, if we're looking at tan x, that would be equivalent to b over the adjacent, which is a. Okay, let's look at sine x in this situation. So that's opposite over hypotenuse, so there'll be b over c. And let's look at cos of x, that would be adjacent over hypotenuse, so a over c. So if we're trying to prove this identity here, we really want to work out what sine x over cos x is. So that's going to be b over c divided by, I've got a over a there, should be a over c, divided by a over c. So I'm just substituting whatever these things are equal to. So b over c, I'm just substituting into there. Okay. Alright, so just remembering back to your fractions, when you have two fractions dividing by each other, we can write it like this. So b over c divided by a over c, and we can write that as b over c times a over c, and c over a, reciprocating, and so our c's cancel out, and all we are left with is b over a, which just so happens is equal to what we said tan is equal to, and so therefore we can say that it's equal to tan x, and that shows that this relationship that we have up here is indeed true. Okay, so that's our second trig identity.